these multiple choice questions. We are going to talk about degrees of freedom. One thing I want to encourage you, right? Yesterday I got an email from Deacon saying, hey, Mr. Kinney, how in the world am I supposed to do these degrees of freedom? And I was able to send you a pretty quick email in response, right?
Okay.
Guys, shoot me an email because, yeah, I know that degrees of freedom. So first off, did you find the formula in the textbook?
Oh, I did.
No.
I wasn't using
I
it.
was
So
on
the
the formula sheet, I couldn't find it. And I gave
It's
up.
not on the formula sheet, but remember I told you to use your notes pages, right?
Those two.
And to go through those notes, because if you went through those notes, you know what you would have found?
That formula.
That formula for degrees of
It was
freedom.
in the notes.
And
It's in the textbook.
it's in the textbook. And guess what? That formula sucks. We're never going to use it. So it's okay. I'm going to show you though. If you had looked at the free response question that I sent, the one I worked out,
I did
there was
look
a
at
note about how to find it. Okay,
it. Well, I
so
looked at it, but I
don't
wrote
let
it
me
down.
forget this. I'm going to erase
Internet
it.
was down.
But let me come back. Don't let me forget this.
Yeah.
All right.
I wrote it down. I just
So,
couldn't figure it out.
let's see. Bryson, which of the following can be used to show a cause and effect relationship between two variables? Why does it have to be an experiment? Why can't it be one of those others?
Because it can't be.
I just know you say cause and effect over experience.
So, do not forget, right? First off, the goal of an experiment, right, is to establish cause and effect. First things first, right? But why is an experiment able to do it and nothing else?
Because in experiments, you can give out treatments, but you need to control it compared to.
There we go. So we can give out treatments. We need controls to compare it to. We also need to remember random assignment, all those things. So like, what are those treatments? What is the random assignment? What is that doing? It's reducing something. Confounding, right? The reason we can establish cause and effect between explanatory and response variables is because of we are reducing the effects of confounding. Number 2. A dog food company wishes to test a new high-protein formula for puppy food. Someone was like, oh, Mr. Kinney, we just did this one. I know. But it's something we need to remember, especially for what we're about to do today. So, puppies participating in an experiment will be weighed at weaning and will be weighed at 1-month intervals for 1 year. In designing this experiment, the investigators wish to reduce the variability due to natural differences in puppy growth. Which of the following strategies is most appropriate for accomplishing this? First off, I got to ask this question. Lexi, which answers would not be valid for this type of study?
Can you re-ask that?
So, some of these answers, A through E, are not even valid for this type of study.
Blocking?
Think blocking? Not sure?
I think
You look like certain. Haley, do you agree that it's blocking that we need to?
No, because it's an experiment. Experiments can have blocking.
So, blocking is a form, or is a method for reducing confounding in an experiment, right? Remember, stratifying is very similar to blocking, but stratifying is for random sampling. Blocking is for random assignment, right? So remember, both blocks and strata are homogeneous, and those blocks are different from each other, right? But blocking is so that we can randomly assign, and stratifying is for random sampling. So which of these, we're automatically down to A and B, right? Peyton, which of these should we go with? Are we going to block on dog breed, or are we going to block on geographic location?
Breed.
Breed, why is that?
I don't know, in my brain, it just makes more sense than geographic location.
Okay, I would agree with that. Make sure we talk with our groups as we're working through these. Can anybody give us either further information on why you agree with dog breed or push back and say geographic location? Leah.
Because if we're just saying geographic location, it could cause a lot of confounding because we don't know that said dog breed. It could be a Great Dane versus a Chihuahua, and what we wouldn't know. Because
So what you're saying is that the breed matters more for something than the geographic
weight,
location?
yeah.
Okay. Haley, do you want to add something onto that?
Different breeds are going to have different growth rates.
That's right. What's the design? What is this all about? They are wishing to reduce the variability due to natural differences in what? Well, is the breed or is the geographic location going to most clearly affect the growth rate? The breed, right? So we block on the breed, right? A Chihuahua will have a different growth rate than a Great Dane. We block on whatever variable we think would have the most variability, and so we separate those into different blocks. So we go with A, right? So Peyton, good catch on breed, but we also want to make sure it's not just, hey, it makes the most sense. We want to make sure we can clearly explain. And so remember, guys, I'm not writing all this out on the board, but can you write some of this information down as part of your study for the AP exam? Yes, Mr. Kenny, I would agree. Okay, number 3 here. A certain county has 1,000 farms. Corn is grown on 100 of these farms, but on none of the others. In order to estimate the total farm acreage of corn for the country, 2 plans are proposed. Sample 20 farms at random, estimate the mean acreage of corn per farm in a confidence interval. Multiply both ends of the interval by 1,000 to get an interval estimate of the total. Identify the 100 corn growing farms. Sample 20 corn growing farms at random. Estimate the mean acreage of corn for corn growing farms in a confidence interval. Multiply both ends of the interval by 100 to get an interval estimate of the total. So what do y'all think?
Plan one,
2?
I said neither.
You say neither?
Yeah.
I said plan one.
So I want some reasoning or explanation. What are we thinking?
You should go plan 2 because there's only 100 farms, so it's likely that out of the 20 you don't get any corn farms.
So yeah, if we want to estimate the acreage, right, of all farms, or corn acreage of those farms, we at least know it can't be which study. It can't be the first one, right? There is a very real chance that we don't get a single corn farm. So estimating the total farm acreage of corn for the county. So why are you thinking 2 instead of neither? Because Ashton was pretty confident that it would be neither D.
I don't know, I just, better than no plan at all.
Oh my gosh.
Plan 2 would work.
It's
All
fine.
right, come on, I need some reasonings, a little bit
I
more.
don't like the plan
I've never
2
heard families.
because
Oh, we say that.
yeah, oh, it's not, I had thought it out. But yeah, so you're multiplying by, what's that, 100 at the end, but you already sampled 10. You need to multiply by 5 because you
No,
have
no, no, they're getting the mean, so it's all down to 1. Before they-
Yeah, because they're getting the mean, and the 20 is an estimate of the mean of the 20. You just multiply it by 5, and that should be the mean of the 100.
So the
Yeah.
mean acreage of corn for corn growing farms. So when we get this confidence interval, we're estimating mu, which is just the average per how many farms?
Per 100.
The average would be per one farm, right?
Facts.
So the average would be, or the, yeah, it's I guess, yeah, average per one farm. But what does the question ask? What are they trying to do? Estimate what? The total farm acreage. So do I want to just, what could I do to this average to get the total acreage?
Oh, it is plan 2. Okay.
It's a great, but that's the debate, that's the discussion, that's what we want to think about, and we want to recognize. Because, man, we should be able to eliminate 1, right? Like, we should say, hey, we're not going to get all the corn farms, right? But with 2, can we get, and so it's the total farm acreage. That was a little bit of a trick question, but that detail was there. So, remember, the average is per 1, and we want to get the total, so it'd be times 100. Questions about that before we continue?
Okay, so it would be,
It was B, yes ma'am.
okay.
It was indeed. All right, we'll pick up with 4, 5, 6 tomorrow. Again, for our review of these things. Just as a heads up, I did, I don't know if I updated the agenda slide. Yeah, we already did all that stuff. Really quick note. I finally finished making, or giving feedback on the Frere models from last 9 weeks. I'll be giving those back today. I did not have everybody's, and so we need to make sure that we get that done and submitted so that I can give you feedback. One other note I will make is this. Hey, the whole point, unless your name is Joseph and you just refuse to do these, the whole point, right, was so that, sorry Joseph, I just had to, take the dig. Maybe one day you'll start to do them. Maybe. The whole point, guys, is this. You are building what with these FAIR models?
Understanding.
Not just understanding.
Oh, study materials.
Right, hey guys, you have a 700, 800 page textbook. Do you want to read 700 to 800 pages?
No.
Heck no. But as I'm studying for the AP exam, I want to have a succinct summary of everything that we have studied. So if I were you, like look at the feedback, because some of us did a great job, right? Like Ashton, I think, addressed every single question that I asked. Lexi got whole new FAIR models and redid some of it, and I did give some small feedback again as well. But if you did not update your knowledge, if you did not, Leah's like, no, I didn't turn it in, I'm aware. If you did not update your knowledge, if you did not update your summaries, then they're not going to be as successful for your studying, right? And those weren't the only ones who updated their stuff, but like I think Deacon did whole new pages as well. Josh, I think, addressed just about everything. I don't remember on top of that. I know some people did update. Those are the ones that stuck out to me. Guys, you can still turn it in. I highly encourage that you turn it in because I cannot give you feedback to help you improve without those turned in. So I'll pass those back at some point today. We are continuing with means and with confidence intervals. And so,
Questions?
I meant to, I know, this is part of those questions, right? So really quickly, right? You should have already filled out your notes for a lot of this. I want to just go over this one really quickly. It's a practice problem. Was this the one on page 5 that someone was asking about? Perfect. So here's what we need to remember, okay? We have heights of seniors follow a normal distribution. The heights of freshmen follow a normal distribution. And so why is it important that both of those samples follow normal distributions?
Because that means you make no subtraction.
So because both are approximately normal, right? The sampling distribution of what?
Maybe the difference. The difference and the difference and the normal.
Now, I want y'all to pay attention to this. And I really need you to pay attention to this. Because some of us on that most recent test, which is why we're putting down our phones, some of us on the most recent test missed this detail, and we just used 1s and 2s on these sample means. But use the context. What would make way more sense to put as my subscripts here?
That's right.
Seniors and freshmen. And now we can change it either way, but like use symbols that make sense in the context, and you're not going to get as lost, right? P.S. Remember, we are staying during advisory today, except for Aaliyah and Joseph. I'm kicking y'all out because you still haven't taken your test. And I'm going to give you your test back, and I'm going to recollect them. I'll give them back eventually. But we're staying during advisory today to go over the free response.
I can have it.
Yep. Sucks to suck. All right. So we are looking at this sampling distribution. So what am I going to start with if I'm trying to find that probability?
Hey, a formula? A distribution?
Say again. Ah, I draw that normal curve. Thank you. Okay. What am I going to make the center of this normal curve?
Zero.
I'm going to make it 0. Standard deviation of?
1.
Okay.
So would you just do 1 for the entire thing, or do like 1 for each sample?
Neither.
Right.
Well, sorry, not neither.
Okay.
1 for the entire thing, right?
Right.
Because I can convert this to what type of value or symbol, right? Because we got numerical values, right? How can I convert this, though, to fit it on this normal curve here?
Value minus mean over standard deviation.
Don't forget, value minus mean divided by standard deviation. And so this is where our formula sheet can come in handy. Oh, by the way, I forgot to mention this earlier, but please note, I passed this flow chart out. This flow chart is to help you, and we're going to talk about it a little bit during advisory, figure out which test, which confidence interval, basically which inferential procedure we need to use. Sorry, Deacon's too good for it. All right. Oh, did I give it to you the other day?
No, there was 1 extra.
Oh, my bad. Sorry, I was in the wrong. Okay, so value. We want to know what is the probability that the sample mean height of the freshmen exceeds the sample mean height of the seniors. So what would the value, the boundary be when I look at the difference here? If we're looking at one exceeding the other.
Above 0.
It'd be below 65.
I would say it depends, right? If it was the freshman being taller, right? And I do seniors minus freshmen, this needs to be less than
Starting question.
0. Could I switch the order and do freshmen minus seniors?
You have to say.
And guys, the reason I bring this up is that's the mistake a lot of us made on the test. Close your ears, Joseph and Aaliyah. That's the mistake a lot of us made on the test is we went the wrong direction because we didn't pay attention to the context, right? Pay attention to the context. So if the idea of the freshmen are taller, right? This one would be less than 0. So what's my value though?
That's the,
Guys,
anything less than,
Just X,
I would say, remember the value comes from my statistic,
X bar.
so it would just be
Can you plug my ear in?
0. No, you're good.
Oh, you don't.
You're good, sorry.
Okay.
Right.
Look, hey guys, Peyton, you with me? Remember the value is from the statistic, and what's the boundary value for this statistic? No matter which direction we go, it is 0. Right? The boundary statistic is 0. Now, when we say mean, that is my parameter. So what is X bar estimating? What is the parameter for the sample mean? Well, just starting here, just in general, right, symbol-wise, Peyton, I need you to focus on these symbols. These are the things you missed before. Headphones out.
Mu of F minus mu of S.
So remember, it's going to be the sample mean. So it's the average of the sample mean. So do you want to do freshmen or seniors first?
Seniors.
Okay, so we'll do seniors first, minus the sample mean of the freshmen. And we need to remember, this is that combining random variables. It showed up twice now. We really need to pay attention to this. We actually don't usually write it like this. When we subtract two variables like this, that's the same as doing what with their averages? Subtracting their averages. So notice what I'm pointing out, and we want to recognize, oh my goodness, I did freshman again. The mean of variable 1 minus variable 2 is just the mean of variable 1 minus the mean of variable 2. And I'm going to jump in a second, but I want to establish that middle ground because it's going to help us remember that if I have the mean of x minus y, that's the mean of x minus the mean of y. Right? Same idea. But what we have found from our sampling distributions is the mean of the sample means is just the what? Population mean, right? So the mean of my sample means is just my population mean minus my population mean. So I'm going to jump to here. If you look at the formula sheet, it goes straight from here to here, but there is that middle step, right? That's why this is my parameter. What are your questions? Peyton, Bryson, Alyssa, you were nodding along with me, so it's making sense. Haley, Lexi. This is an important review piece. I'm trying to review as much as possible while teaching new stuff. Okay. All right. So, mean of seniors minus mean of freshmen. What do we get? What is it?
3.
Yes, 67 minus 64 is 3, right? Thank you. So, don't forget, we've got a formula sheet. Now this, oh my goodness, numbers, they matter. Standard deviation. So here's something I got to point out. Bryson, can I add and subtract standard deviations?
No.
What do I need to add and subtract?
Variance.
Variances, thank you. Josh, do I add and subtract variances? Just add. It does not matter, right? When we talk about spread always what? Increases. If you took a chemistry or AP chemistry class, I think the term is entropy, right? Entropy only increases, right? So it's the same idea. Chaos only increases. So we do not,
That's more of a bio thing.
It's super heavy in chemistry as well, at least when I took chemistry.
I don't remember that.
I don't remember it.
They talked about bio.
Okay.
They talked about.
Regardless, I promise I studied an AP Chem, it was on my AP Chem exam, that's all I
Heck
know.
no.
Alright, so I only add, right? Remember, this is following what really important theorem that we studied in the past?
Pythagorean.
Pythagorean theorem, right? C squared equals A squared plus B squared. And then looking at our formula sheet, again, we're just breaking this down as a reminder of some things. because we can just jump to this on the formula sheet. How do I calculate the standard deviation of the sample mean?
It's a standard deviation of the population over the, and
Remember, it's population standard deviation divided by the square root of n, right?
Yeah.
And so when I do my variance, right, it's going to be the population of the seniors, or the variance of the seniors, divided by the sample size of the seniors, plus the variance of the freshmen divided by the sample size of the freshmen. So that's what we're looking at there.
So why,
Go for it.
over on the z-score is your value 0? What's missing?
So remember, what we want to know is what's the probability the sample mean height of the freshman exceeds, right? So if
Yeah.
it exceeds, then it's less than 0, right? If I subtract and that's bigger, what am I going to get?
Wait.
Starts with an N. If this is bigger,
Negative.
say it again.
Negative.
Negative, and negatives are what?
Less than 0?
Less than 0. If I have the freshman first, right,
Yeah.
then I would get a positive because that would be bigger, and a positive is greater than 0. So you can do either direction. We decided to go with this one, right? But no, so that's saying the same
Will it
thing.
always be 0 or no?
Well, it depends on the language, but if you think about your two sample inferential statistics, hasn't it always been all about 0? Think about your hypothesis, right?
Yeah.
P1 minus P2 is equal to 0, P1 minus P2 is greater than 0. So a lot of times it's 0. Yeah. All right. So 4 squared divided by, what's the sample size? 10? No, seniors is 12. Plus 3.5 squared divided by 10. And then we just have to take the square root of that. Does anyone remember what that was off the top of their heads? Did we do that calculation?
it's 2.5583.
Thank you. 2.5583.
Yeah.
And so what we're looking at is the probability that z is less than a negative 1 point something.
I have a random question.
Go for it.
I was just thinking about it. If the seniors on average are greater than the freshmen, then why, if you subtract the freshmen from the seniors, it's less than 0?
Because that's not what the question
That
is.
freshman is bigger than.
The question is, yeah, what is the probability that the sample mean height of the freshman
That makes sense.
exceeds the sample mean height of the seniors?
Hey, Mr. Kennedy.
Because like it's possible that our sample of freshmen is bigger. Yeah.
That's the variance, the 2.5.
Oh man, why'd you lie to me like that? All right.
Yeah. The standard deviation is 1.5995.
I feel lied to. I feel betrayed.
Wait, so you take the standard deviation of the
Huh?
variance?
why you have 1.599.
Oh, okay, okay. Now that you have the square root thing on.
Wait, you take the square root of the variance?
I-
right?
Hold on. Say that one more time, Mr. Ellis.
When you take the square root of 1.599.
Yeah. But that changes my z-score. Negative 1.86, right? So negative 1.86, and then which direction should I be shading? To the left, right? It's less than in this case. So, this is going to help us with some later things, but what we want to recognize is we're just using our normal distribution, finding the area under that curve. And so again, this is why whenever I see normal distributions, I'm not just doing whatever the actual mean is and whatever the actual standard deviation is. I convert it to my z-scores and I work from there because that's way simpler in the long run.
So why in the z-score formula?
Oh, by the way, go ahead and find that probability while he's asking this question. Say again.
Why is the standard deviation squared again on that? Or not squared, but
So remember this, so if I don't take this square root, I still have the variance, right?
Mhm.
And so,
But you already have that squared. Did we not square it over there?
so remember I did the variances all the way through here. And so that was not the standard deviation, that was the variance. And so I had to take the square root.
So after taking the square root of that over there, you take it again?
No.
Or is that-
The square root of that is, so notice I hadn't taken the square root.
Oh, okay, that makes sense. Okay.
That's my
how it
variance, so I
works.
took the square root.
Why did you change to the left?
Because remember, the way we were doing it is less.
Okay, yeah,
Right.
gotcha.
If we had flipped it, right, it would have been greater.
I got you.
But we would have gotten a positive 1.86. And that's why it's important to define our concepts from the beginning. Yes, sir?
So after finding the variance, where did you put the variance into? Like what equation?
I didn't. Remember, that what I need here is standard deviation, right? Standard deviation is just the square root of my variance.
Oh, so you just plugged that in and found Z
Right.
for that.
So remember, if you look at your formula sheet, the standard deviation of sample 1 minus sample 2 was the square root of the standard deviation, or the variance of 1 divided by n1 plus the variance of 2 divided by n2. I just showed the steps of how we got there. Notice I didn't have the square root here.
Yes, sir.
What I should have done was gone ahead and drawn that square root in to fit the formula sheet.
Yes, sir.
We hadn't taken the square root yet, right? So I had to take the square root of my variance to get standard deviation. And that's the thing, right? Value minus mean, right? Value is my statistic, minus my mean, that's the parameter, divided by the standard deviation. Okay? All right. So at this point, you can do progress check A.
Yay.
I will not make that, we will not be able to take the demonstrate your understanding until, I guess really we could do one tomorrow, but I'm not going to make the progress check due tomorrow. I'll make the progress check due sometime this weekend, but go ahead and start doing it. I got to think about if we're going to do it demonstrate your understanding tomorrow.
We should do one Monday.
Hey, so right here,
Oh, it'd be
we already
tomorrow.
did we already do this problem with Chips Ahoy and Great Value?
Yeah.
That's what I thought. Okay, so we did it on Monday. I thought so.
What are you talking about?
Hey, excuse me guys, we got an AP exam, we gotta stay focused.
This is a difference, so I don't,
Say again?
I don't think we did this.
We didn't do it.
You assigned this yesterday.
Oh, I signed, this is the one I sent to
This is
you,
the
the
one you sent
solutions
to
to
me.
I just
y'all.
wanna make no sense.
That's what happened.
It's like-
It was really confusing. I mean, I wonder if
Okay, so, hey guys, I'm not gonna write all this stuff, because we ain't got time for all that. But if it asks for constructing and interpreting a 99% confidence interval for the difference in the mean number of chocolate chip cookies, first off, I want you to look at that flow chart that I gave you, right? So look at that flow chart, right? So what's the first question we gotta ask ourselves? It's right there in front of you, dude. So what's the first question? Type of data. Are we dealing with categorical or quantitative? What is this? These are the number of chocolate chips. I'm measuring that, right? I'm counting it. We've been doing categorical with proportions, right? This is why I'm asking all to pay attention to this flow chart now. So we got quantitative. Again, this is all review. How many samples do we have?
Two.
Two. Chips Ahoy, Great Value, right? So we see the number of samples there, 1 sample, 2 sample. And so now we go to that right side. So do we have independent samples or do we have paired samples?
I would say they are independent.
Yeah, one's Chips Ahoy, one's Great Value. They're not paired together. They're independent samples. And so what you would want to write there, first off, is this are we looking for convincing evidence or are we estimating a parameter? What's the question say? What's the question say?
99% confidence.
It asks for a confidence interval. What's the point of a confidence interval? It is to estimate a parameter, isn't it?
Yeah.
We're 99% sure that the interval from blank to blank captures the what? Parameter. What's convincing evidence? That's the hypothesis test.
But you wrote on the thing convincing evidence.
But look at,
What?
but that's because of question B, right? Question A is confidence interval. That's estimating a parameter. Based on estimating the parameter, is there convincing evidence? So, again, as always, what are the 4 steps we got to do here, Alyssa? State, plan, do, conclude. All right, we're going to get plenty of practice with this moving forward, but I do want to address one thing really quickly. Plan, right? Random, got it. Can we safely say that this number of bags of cookies is less than 10% of the population?
Yes.
Yes. What about normality?
CLN.
mean CLT,
Yes.
central limit theorem.
What I call CLM, yeah.
Okay, central limit theorem, can we use central limit theorem here?
No.
Do not forget, we cannot use the central limit theorem because the central limit theorem requires a what?
Outside of 30.
A what?
A sample, she said.
Of at least,
Significantly larger sample size.
there we go, because we need to be careful, because on the AP exam, 30 is considered sufficiently large, but the language is you have to say a sufficiently large sample size. And do we have that?
No.
That's definitely not sufficiently large. If you looked at the solutions I sent, hopefully you did, because I don't got time to go over all this, but if you look at the solutions I sent, how did I check for approximate normality here? I created a box plot, right? I created a graph of this data, and there was a little bit of skewness here, but there wasn't strong skewness. Because both of these were roughly symmetric, I believe that it is possible that the sampling distributions or the population would be approximately normal, right? That's what you need to talk about, right? When it doesn't satisfy the central limit theorem, when you don't know the population is normal, okay, let's graph this and let's check to see, is it symmetrical, is it roughly symmetrical or not? And so that's how we checked our thing here.
I just have a question. So on your,
Well, Austin first, because he got his hand up. What's up?
So, at one point, do you call it convincingly skewed?
When do we,
Like,
say it one more time.
at one point, do you say it's skewed enough to not be normal?
It needs to, we would say there's not strong skewness, and as long as there's not strong skewness, we'll proceed with the,
But like, at what
Procedure.
point is it strong skewed?
yeah, exactly.
it'll be clear on the AP exam. Like, I wish I was kidding, but literally, like, if you look in the book and you read the book pages in the book, like, what do you think? Is that strong skewness or not?
That's strong.
That's strong skewness, right? Okay. What about this? So I put it here, and here's my median, and it goes like this. Strong skewness or not?
That's pretty fine.
I guess
I
not.
do.
I would say, to me, like, if you have to go, it's kind of skewed, is it strongly skewed?
I got you.
I
Yeah,
guess
it was
not.
fine.
Yeah,
That's the question you ask. Like, if you have to go, it's kind of skewed, then it's not strongly skewed, continue.
Alright.
Does that answer your question?
yeah.
Okay, so that's what I would say with that. Now, let's quickly look at this, because I want you to always, one, pay attention to the formula sheet, but we do, or not formula sheet, the textbook. But we got to get started with the rest of today's lesson. So what is this, chapter 10? Okay. It's chapter 10, I promise.
Wait, we didn't talk degrees of freedom.
What do you think I'm doing right now?
Okay, I guess we're talking about like degrees of freedom.
Yes. All right. So right here, here's the degrees of freedom formula.
Yay. Oh no. Never mind. I don't like that.
I hate
You
that.
want to remember that formula?
No, I
No.
can't
Heck
remember any
no.
formulas.
You cannot, you don't need to remember that formula anyways.
-1.
Honestly, that's not even that bad.
Not when it's two sample.
It cancels most of the stuff out anyway.
It does not. None of that cancels.
Kind of like it.
Because this whole thing is squared. Say it again, Lexi.
Just do it in the calculator.
So here's the thing, and you don't even have to know that formula for the calculator.
Sure,
If
right,
you
yeah.
run the confidence interval, if you run the hypothesis test, you know what it's going to spit out? The degrees of freedom, right? So quickly, I need everyone to pick up a calculator. Okay.
Whose
Let's
idea
run-
was this?
I don't know. I got to read. Deacon was asking the same thing. All right, so I'm going to do great value, and I'm going to do Chips Ahoy. So enter your great value number of cookies in there. All right, so great value 2220.
That's Walmart brand.
You're a Walmart brand.
Ooh.
You're a Dollar General brand.
Hey, at least Dollar
Hey,
General
why
brands are
are you on Dollar
actually
General?
good.
Dollar General's dope,
Dollar
actually.
General's not.
They do have.
Okay, rich guy.
Okay, hey, all joking aside,
You
get
cannot
those
talk
numbers
about
in there quickly, because we gotta move. Okay. So. Okay, you got your data in there? So list and spreadsheets. Yes, ma'am?
We need Chandler Carpenter's bag. I think
Here you go.
his name.
Is it his phone?
Yeah, it's not up there.
Thank you.
What's 36?
It's a case. Not a phone. Alright, while some of y'all are still finishing your data, I do want to show you this really
Wrong
quick.
second is a really big number.
It really be you.
It was almost second 100.
So, notice right here, you can look at this dot plot, you can convert it to a box plot. So, that's pretty darn symmetrical. Can we all agree on that one for great value?
Yeah.
Yeah? And then when I look at Chips Ahoy, that's somewhat skewed, but is it strongly skewed? Yeah. Right? So notice I would just create this on the calculator and I would quickly sketch it. Alright, hopefully we have our data in by now, right? For Chips Ahoy and for great value, it's also right there in the notes page, because I'm about to move forward.
How do you convert a table to a graph?
Yeah, I forgot to do that.
Add a page, remember?
Oh yeah, that was.
Right?
Makes
What
sense.
type of page do you create to get that graph?
A graph.
Nope, not graph, huh? Data and statistics is what you want to be able to add a data-based graph.
How do you add?
Control and then doc. Remember how it has plus page in gray above doc?
There it is.
Yep, Okay, but I've already shown you the graph. I need to focus here. So what do I need to do for a confidence interval now?
Maybe font T.
Press menu, that's right, because everything cool runs through menu. Okay, so I hit the menu button. Yeah, what are we doing? We're trying to deal with statistics. Where are we going to go from statistics? Trace, confidence intervals. What type of confidence interval? Why are you doing a T interval? Why not 2 sample Z?
I'm so lost.
We do not know the population standard deviation, right? Now remember, there's data method. Do you actually have data or do you just have summary statistics? We have actual data. We have not done the statistics yet, right? So go to data, and you're literally just going to be able to put your variables in. So I'm going to do Chips Ahoy. I'm going to do great value. Okay, what confidence level are we doing? Do we pool?
Oh, wait a minute. I just
No, we don't.
We never, ever, ever pool our data. Don't ever put pooled data. It's not as accurate.
We're doing T. Okay,
Two sample T.
Oh,
Two sample T, huh?
Why is that there?
So it's a valid statistical method, but with AP exam, it's not as strong, so we don't do it.
What's frequency 1 and 2?
Well, how many times are you putting Chips Ahoy list in there? Once, right? Great value, once. But don't worry about it. Don't do it.
That's
Okay.
bad, lost.
I was just asking.
I can answer it later, but like right now we gotta move forward. But so also I will say this. Remember, Tyler, when we did probability stuff, and we had our random variable, and then we had our probability that went with that random variable.
Yes.
Do you? So like I have X, and let's just say these are my values for X, and then we had the probability of X, and it's like 0.25, 0.35,
Yeah.
0.1, 0.1, and 0.1. First off, would that be a valid probability distribution?
It looks like it, I think.
Why do you say no, Joseph?
Doesn't add up to
Remember, what does the probability have to add up to? 1, right? Doesn't do that, that wouldn't be valid. But in this case, Tyler, that would be my variable. This would be my frequency list because it's showing how frequently each of these values show up. Does that answer your question?
Yeah.
So, all right. So, confidence level. Say again.
I don't like the frequency list.
I don't even know what I'm
It's
doing.
not very often you're gonna have to do it.
Okay, good.
All right, right here. Notice it gives me my lower bound, my upper bound, my mean difference, and what does it give me right here?
Degrees of freedom.
Degrees of freedom. So when you run the inference procedure, it gives you the degrees of freedom. That ugly formula that you saw, it gives you your what? degrees of freedom.
I know, dude, I'm trying to go box plot.
Hey guys, right now I need you to focus on this because there's one last thing I need to show here before we do the next part of today's lesson.
Bro, I don't even know what to do.
It's all good.
But what is the degree of freedom for? Like, what is it?
So remember, every time, so first off, when we don't have the population standard deviation, we can't use a normal distribution. We have to use, so here, let's say this is my normal distribution, this is my z distribution. We have to use a t distribution, and what a t distribution does is it's a little bit wider, okay? And the more you increase your degrees of freedom, right? So remember, degrees of freedom is based on my sample size. And the more you increase your degrees of freedom, actually the closer the t distribution gets to the standard normal curve, okay? And so like this might be a degrees of freedom of, I'm making this up, at 5, right? This blue one right here, I should say. The brown one may have a degrees of freedom of like 15, and this one right here may have a degrees of freedom of 30. And so when my degrees of freedom increases, it's going to approach and get closer and closer and closer to the standard normal curve. But the degrees of freedom defines which t distribution we're working with. It's necessary to know. So like the lower the degrees of freedom, and think about it this way, the lower our degrees of freedom, the lower our sample size, the more spread that data is, right? So notice how this lower degrees of freedom is more spread out to get the same amount of area. So that's why you need degrees of freedom. Logan. So if your degrees of freedom is like greater than, I would say probably 100 or 200, it's really darn close. And if your degrees of freedom approaches infinity, it becomes the standard normal curve. But your degrees, right, but your degrees of freedom has to approach infinity, right? But it is approaching, and that's something you want to notice. Okay, Peyton, you still getting sleep at night? You sure?
That's a good.
Kind of? Okay.
How do you do the box plots?
Yes, please.
Because you're gonna need this for playing.
We're going to talk about it in a second, later. Okay. Right now, I want to address two things. One, remember you're going to need your t critical value. Did the calculator give me my t critical value?
Basically, it gives you your margin of error.
It does give me my margin of error, but does it give me my standard error to figure out what t is? No. So, hey, right here, okay, every t distribution is defined by your degrees of freedom. So what we know is we have what level of confidence? 99, right? And so like if I was thinking about my normal or my t distribution curve, what percent of the area is less than this t star right here?
0.995.
Remember how it'd be 0.995, right? 0.99 in the middle, right? And 1% between here and here, so 0.05% there. And so now I have the area, and do I know the degrees of freedom for this t distribution? What is it?
13.
All right, I want you to use your calculator. With that information, find what t is. Think about how we have done that in the past. Again, trying to build review into this. So let's figure out how to do this. Remind ourselves of how to do this. You have the area lead on what's a critical value.
Yeah, I did the same thing.
Right.
And it won't let me get.
Now be careful, do we have a normal distribution? What do we have? So we need inverse over inverse t. Okay. Make sure we're, and don't forget, you can just also hit those numbers and it'll jump straight there. Okay. So you'll have to have a calculator, guys, sorry, you have to have a calculator page to be able to do it. I should have said that earlier. Say that again, Josh.
I would say have an area.
Yep, so remember, there's a 99% confidence interval, not 0.995.
We already did the confidence, didn't we?
Okay. So,
I highly doubt it. I think you can do calculus for that one. Calculus, I think you can do that one.
all right, does anyone remember what the z star for a 99% confidence level was?
You don't want 1.8.
That's 95%. Because what? 2.576.
Yeah.
Notice, what was this T star, this T critical value?
3.2.
Something, I don't remember, something like that, right? Notice how this T is larger because what do we have to do? We have to spread out further to be able to capture the same percent of data, right? So that's what's happening there. Last thing I want to point out, because y'all are asking about this, would be, does this interval provide convincing evidence that there's a difference between the two brands?
No.
Why not?
Because 0 is captured by the end of
0 is a plausible value, right?
Here.
And if there's a difference of 0,
There is no difference.
then there could, well, be careful. Do we know there's no difference?
No.
No, it's just possible that there's no difference, right? So we need to be careful with that. The value of 0 is inside this interval, so it is plausible that there's no difference. We don't know for sure, because do we know what the parameter is?
No.
We are just estimating the parameter. It is plausible that there's a difference of 0. All right. There's some homework associated with that if you need extra practice, and I can answer those questions in class. But here we go. This is what today's all about. Reducing cholesterol. I know y'all really got to worry about that, right?
Yeah,
I love my cholesterol.
I love my cholesterol. All right. So look, here's what we're gonna do.
The highest.
First off, I'm pretty sure the notes are back here. I planned on doing this activity next chapter, but I am deciding to jump ahead. Oh, can you pass that? Okay, so we're gonna have to go and find what page it is on in our chapter 11 notes. Hey, guys. Gosh.
Better than usual.
So, page 4, listen, page 4 in our chapter 11 notes. Mr. Arliss is passing out chapter 11 right now. Yeah. So this is going to help us understand paired data. All right. So, the context of this is this. A pharmaceutical company, right, has developed a new drug to lower cholesterol and wants to compare it to the drug that is currently being recommended by most doctors. To do this, the company recruits 20 male volunteers, all a similar age. Half of the subjects will be assigned the new drug, and the other half will be assigned the current drug. So first things first with this problem, this situation,
Cholesterol.
what type of study are we looking at? Why is it an experiment? Okay, well, first off, the researchers are assigning the recruits, right? Okay, why else would it be important that this is an experiment?
You're trying to establish cause and effect.
I'm trying to establish cause and effect, right? I've got two what here?
2 different drugs.
2 different drugs. What would you call those drugs? Treatments, right? Statistical language there. We got 2 treatments. One of those treatments would be called my what, Logan? Specifically, the old drug would be considered my what?
Yeah, where are we?
Say again. Page 4 in chapter 11 notes. The notes that Mr. Arliss just passed out. We're going to go back, but this is a better activity than what's in the chapter 10 notes. That's why I changed it.
Chapter 10.
So bottom of page 4, right? Okay. So, sorry, bring it back. Logan, what are we going to consider that old drug in this experiment? Huh? The control group, right? We got to compare it against something. So we got 2 treatments. We got our old drug. We got our new drug. And now it talks about male volunteers here. Is that okay? Why?
Because they're still randomly assigned.
Okay, they're still randomly assigned, but not just that. Why is it okay that we have volunteers in a study like this, in an experiment?
There's no selection bias.
Because we're just reducing what? Confounding. What are we not concerned with? Bias. We only want to establish cause and effect. We're reducing the confounding. We don't care about the bias in this case.
Why don't you care about bias?
Huh? So remember, bias is only an issue when we are trying to make a prediction about a population. So with an experiment, the experiment is not concerned with making a prediction about a larger population, just an experiment, or just cause and effect. The other thing is, most experiments you cannot do random sampling. Why can you not do random sampling for something like this?
You can't.
So you have to have consent.
Yeah, you have to have consent. Can you force somebody to take a new cholesterol drug versus an old one?
I mean, you can.
No, that's unethical.
I understand.
We did some wicked unethical things in the 60s and 70s. We got away from it. That's where the Stanley Milgram experiment came from. All right, right here though. Hey, bringing it back. I need us to pay attention to this. Why do they only have male volunteers?
Because
They were just
Confounding from effects of female.
Right, so it's different for males and females, so it could be what? You were saying it just a second ago, just confounding, right? If we use male and females, there could be confounding there, right? Okay? Why do they do all similar in age? Because age could be a confound, right? So, huh?
Why don't they just get everybody and then block it?
Ah, that's a possibility. They could do that, right? That's a good question. All right. We're actually going to look at some of that idea of blocking in a second. But again, hey, really quickly, what element of experimental design are we using when we only use males and we only use similar ages? That's the element of direct control. What element of study design are we using when we assign those drugs, or what element do we need to use?
Random assignment.
We need to use random assignment. So remember, all of those design elements are intended to reduce confounding. But can you always reduce confounding through direct control, through blocking and all that stuff? That's the whole point of random assignment. Random assignment filters out as many of those confounding variables as possible.
What's an example of indirect control?
There is none.
Then why don't they just say regular control?
Well, because
okay,
you're
I guess.
directly controlling. Yeah. All right. We're not going to talk about type 1 and type 2 error in this context because we're mostly doing this as confidence intervals. So here's what we're about to do. I'm about to pass out these subject cards to each of you. Does it matter who gets what subject? Why not? Is it? If I'm giving this to you, is it random?
Guys, plot twist. It's all the
Not
same
really.
thing.
I didn't shuffle them. Do
Placebo.
when you say random, we need to be careful. Random sample versus random assignment. Is this random, me handing out these subject cards?
Yeah. I'm just walking up to people and handing them out.
Guys,
It
plot
could
twist.
be, but hold on. If I'm going to claim random sampling, I need to know it's random. Am I using a random number generator to randomly assign?
You are not.
I am not. So is this random sampling?
No.
No. Okay. So every person has a different card.
That is not randomly selected.
Okay. Oh, Mr. Arliss, you need one as well. Okay. Because remember,
Any old person.
y'all, hey, what is our characteristic of interest? It is not.
Thank you.
Excuse me, Austin. Thank you. The characteristic of interest is not the person, but it is the treatment, right? Whether we are reducing the cholesterol as much as possible. So what do I need to do randomly?
The subject number.
I need to randomly assign the treatment.
It's a healthy
Tiny.
cholesterol.
Okay. Fantastic question. Got no clue. All right. But here's what we're going to do. All right. So we're going to do a completely randomized design here. What do I need to do in order to do a completely randomized design? You will have to describe random sampling and random assignment more than likely on this AP exam. So what do we need to do to make random sampling?
Assign every person a number.
Okay, so that is it, that's label, I think is the term we use, right? So we label, we assign each subject a number. Have I done that?
No, wait.
Yes.
Oh yeah, I guess now.
I have, yeah. Okay. Now label, assign each subject a number. Label and then, so yes, so so I think the term we used was,
Random number process.
we said generate, right? And we need to use a random
Process.
generate. Well, we're going to use random process, but right, so, hey, and by the way, the reason why they say a random process in the book is because there is a way to like just mix everything into a hat and draw it out. The AP exam accepts that. There's a random number table. You could use a die technically, but that's not what I recommend. Random number generator is better. So random number generator to do what though? Well, like, how am I gonna decide?
You could do 1 or 2, or you could do like a 0
Even max.
through
Just do
4
1 or
to
2.
5 through 9.
So there's a couple of options. I'll say this, right? If I do 1 and 2, how am I gonna use 1 and 2 to randomly assign treatments?
Give them one or
Could
two.
do 1 as the control, 2 as the new drug, and then randomly generate it.
But how? Like, how am I gonna decide? And so,
Oh wait, I think we
Even
need
some
to fix
odds.
the label,
Okay,
right?
right, 20
Yeah.
numbers.
not necessarily.
Like add number from.
One goes to even.
Well, but that's,
odds.
so we assigned each subject a number. That's okay. We can do it this way. We could also do a number 1 as control, number 2 as a new drug. But, so I'm gonna show you what I recommend in a second, but this is a valid way. But if you do it this way, Lexi, what are you thinking?
I was just thinking about doing even and odds, because you're not just gonna have 1 and 2, right?
And like,
I mean, so remember in a random number generator, you can define which numbers you're doing. You can do a minimum and maximum, so you can do that. But if you're gonna do it this way, what I would have to do is I would have to go up to Deacon, randomly generate a number, and if I get 1, he's getting what?
The control.
The old drug, the control. If he gets 2, he's getting the
New drug.
new drug. But there is one slight problem you have to be aware of with this system. What is,
Mr. Kenny,
yeah? Hello?
keep on your fingers, please.
Yes, ma'am?
Thank you.
Hey, Mr. Kenny, why you do this?
Huh?
Lock in.
Log in. I mean, I did it for first vlog. That's all that matters.
Yeah.
I did.
Yeah, if he says
Mr. Kenny, second one.
Y'all show up most of the time.
not all.
Unless you will.
I almost said it, but I didn't want to call him out. See, I posted first vlog. All right. We still got 25 minutes, and we need all 25 minutes. All right.
I need to go to the restroom.
Me too.
So listen, okay, look, if I go up to Deacon, right, I randomly generate whether he gets old drug or new drug. I go up to Austin, same thing, Joseph, same thing, or Will, because I don't, y'all call him Will, he told me Joseph, I don't know. Anyways, moving from there though, what could be a problem with that design?
You get different numbers.
Could I get more with the new drug than with the old drug?
Yeah.
It's very unlikely, but is it possible that everyone gets the new drug?
It is possible.
So if I use this system, what do I have to do?
You have to alternate.
Maybe. What I would do probably is I would just say once I get to 10 of the old drug or 10 of the new drug, everybody else gets the other one, right? So like it may be old, new, old, new, old, and once I get half of us that have the new drug, the rest get the old drug. Or once half of us get the old drug, the rest get the new drug. But I'm going to show you a different system in
I
a
just
second.
realized, do you want it to be even or can it be different? Like numbers?
You typically want
wanna
an even
have
number
even amount.
in each group.
But maybe if it's random, the odds of you getting exactly even are pretty
Which
small.
is why.
Well, that's why I'm about to show you the system I would use. Yes, Haley.
Since you already assigned each subject a number, could you not just like if there are 40 people in the sample, could you not just tell the random number generator to randomly generate 20 numbers from 1 through 40?
There we go. That's exactly what I would do is I would randomly generate, and I will say this, we actually only have 14 people participating because we only had 13 plus Mr. Arliss helping. But what I would do is I would randomly generate how many numbers? 14. No,
That's 7.
10.
I only need 7
Would that be
without replacement.
without?
okay.
Because
So-
then you have-
So because I don't want to get 2 and 2 multiple times, right? So I'm going to use a random number generator to generate 7 different or unique, I'll say it that way, unique numbers. And those 7 get what? Like I've already done random assignment, so
Treatment 1.
let's say it's treatment 1, so those 7 get the old drug. Rest get new drug.
That's smart.
Would that mess something up because of like independence?
Or is it easy?
Nope, because you randomly assign 7 unique numbers.
And those others.
So because it's unique, right? Everyone has an equally likely chance of being assigned a drug. Does that make sense? Now, once I do, think about what your question is, because it looks like you still have a question. Let me know when you figure it out.
It's like when you pick the first person, the next person has a higher chance of being picked.
I see what you're saying. So that might be an issue. No. Let me think on that. Don't worry about it, but I'm gonna think about why not to worry about it. But I think because it's an experiment, so that's with random sampling, not with random assignment. Because with random assignment, I'm gonna use everybody.
I just realized, okay.
Does that make sense? Okay. Now, once I generate, I need to select, right? Well, and I guess that would go here, right? We are selecting those 7 to get the old drug, the rest get the new drug. Yes, ma'am?
2 questions.
One answer.
With, like, randomly generating and assigning, couldn't you just do even and odds and then randomly select what gets put with the even and what gets put with the odds? Would that work as well? Because it would...
No, because you already have the numbers, right? You're already a volunteer. So that was part of the labeling. We assign each subject a number.
Yeah.
Then we randomly generate 7 unique numbers. Those 7 or half, those 7 get the old drug.
Okay.
That's going to be a more efficient system. I'm going to think about what you're asking to see if there's another way to answer it. But all right, so I'm going to go to probability.
Can I use the restroom?
Run like the wind, bullseye. Random integer. So I will say this: there are 20 total cards, but because there's only 14 of us, I've only used 14. So I don't remember who all is out there and who's not. So I'm going to generate 10 numbers actually. And so the first 7 will be the ones who get the old drug. Okay, so does anyone have number 19?
Yep.
Who has 19? Okay, so you get the current drug, the old drug. Anybody have the number 3? Current.
What'd you do?
Anybody have number 11? Current. 9.
For cholesterol.
Anybody have 9?
Let's go.
No 9. Okay, so how many have I done so far? 1, 2, 3? 15. Anybody got 15? Nobody with 15. Anybody with 1?
Would it not be a problem to tell the subjects which drug they're getting?
So that could be a part of it, maybe one blinding in there.
I'll twist
Do you actually think mentally knowing whether you have the drug or not would affect your cholesterol
Yeah,
level?
I think that
100%.
you
No.
can-
So maybe, right? So then yes, you might want blinding in there. Hey, guys, we gotta get going. If your number's up there, let me know.
I can't see that far.
1, 7, 20, or 5.
I got 20.
Alright, raise your hand if I've given out a current drug treatment so far. Like, raise your hand if you got one. One of y'all got one, didn't they?
Oh, I got one.
Thank you. 1, 2, 3, 4. So I gotta generate some more.
Mr. Kitty,
Dang it, that's not what I wanted.
I'm telling my mom that you gave us drugs in class.
100%. Alright, 6. Anybody have 6? 3. We already had 3. 2. Anybody got 2?
I still haven't picked.
So that's 6.
Oh, I just remember we.
We already did 15. 1, 9, 7, 20. Apparently gotta do it again.
Is it? I thought match spirits was like similar.
Hold on, we ain't there yet. Chill.
I was just asking.
17. Anybody got 17? Alright, Mr. Arliss got current. If you have not had your name called, let me know.
I got 13. Right.
There we go. Oh, 13's up there. No, wait, 17 was first. Just kidding, we're good. Alright. So,
10 and 10.
anybody else not have one yet? You already have one? I don't think either of them.
Mr. Kitty, I don't have one.
Okay.
I have 69.
Alright. So, everyone I just handed it to should have the new drug, is that right?
Yeah.
Yes? Okay. Now, here's what I need each of you to do. Okay? On here is going to be the total reduction of cholesterol. You will notice that there is an individual, so if you look at the back of your card, there is an individual effect. Put that under individual. There is a treatment effect. That treatment effect is on the card I just gave you. And then there's a random, because everyone's a little bit different, right? So for that random, I need you to pick up your calculators.
Okay.
Okay? Once you pick up your calculators, I need you to go to probability.
Can we see that?
Nope. Probably, actually, we do need a seed.
Yeah, every time it's like everyone attempts
Yeah.
at the same time.
So hold on, probability, random, do random seed, put your date of birth in there. Okay.
My date of birth is
Okay. Yeah, that's all it should be once it's done. Okay.
We're really on that.
Once you've randomly seeded, I need you to go to random normal.
They're normal.
Yeah, random normal this time.
What is the difference?
Well, what do you think a random normal is going to follow?
A random normal.
A normal distribution, right?
Yeah.
So a random normal follows a normal distribution. What you're going to want to do is enter the mean, which we're going to use a mean of 0, and a standard deviation of 2. So do rand norm 0, 2, and that's what you're going to put under random. And that's going to tell us what your total cholesterol reduction is.
Why'd you do standard deviation of 2?
Huh?
Why did you do standard deviation of 2?
Because I chose to do 2.
Okay.
But like,
Are you trying to figure out how to get there?
That's
So-
an error.
Did you do rand norm 0, 2?
oh shoot, I got.
Oh, I didn't put the comma right, that's my bad.
Yeah,
I got a very different.
Well, it should because it's random normal, right? So, hey guys, listen. If the mean is 0 and the standard deviation is 2, some of us are going to have what kind of numbers?
Big ones.
Big or little.
Positives.
Negative.
And some people have negatives. Make sure if you have a positive, you include the positive, negative, you include the negative. And so I need you to write down the total cholesterol change on your form, and in a second I'm going to get all your data values.
Which part is that going to?
Independent cholesterol, treatment, and
And then random normal, yeah.
So initial
Okay.
cholesterol goes with
And so summit. Random normal.
Is this number back
And then mean of 0, standard deviation of 2. And then 2. Alright.
Should I calculate now?
starting
Okay, so individual is our individual effect. Treatment is our.
Just so you know, I'm about to send out a file to everybody.
Whoa.
Oh my, it must be so tough that I've already set up all the work for you. Oh wait.
So do we open or go to?
Open it. Yep. Open it. Don't save anything. Okay.
Can you send it out?
Okay. So remember, you can hit the little scratch pad and do the addition there if you need to. But I need you to find out your total cholesterol change and write it down.
Yo, what?
So we put down like our subject, cholesterol. I think someone already.
I already filled out a lot of the data. Guys, don't type anything in the calculator yet. I just need you to write it here. I'm about to show you where to type it. Not the minus 350, just what your total reduction was, the 110.
Wait,
Right, so don't add or subtract your original value. I just need your total cholesterol reduction.
Wait.
You're good, that's it. Some people were finding out what their new cholesterol was. Yep.
Wait,
All right.
Wait, what do you mean total cholesterol? Oh, wait.
Add those numbers together, dude.
Okay.
There you go. All right. So here's what I need us to do. Subject 2. What was your subject 2? Did you get the new treatment or the old treatment? Subject 2. Who's subject 2?
I got the old treatment.
So you got the old treatment. So I put that as in this column as no treatment, right? So no treatment. And what was your total reduction in cholesterol?
7.96.
7.96.
So I put in 1 if it's.
Okay. So 17. Old or new?
Old.
You got old. So what was your total reduction?
10.55.
10.55. Okay, after that, and so you could be typing this in as well. Subject 3, what did you get for your total, or were you no treatment or?
Mine's 22. Mine's 20.
You had the no treatment, the old treatment? Okay. What was your total reduction? 19.02. All right. The next subject was 6. Who's 6?
Wait, bro.
Did you get the new drug or the old drug?
I think I got. I got current, so I guess I'd be old.
Current, yeah.
Okay.
Wait, Mr. Arliss, didn't you get the treatment, the drug?
I got the current.
Did you just wrong?
Raise your hand if you got the current drug.
Do you,
Is that everyone? Did y'all get
No,
that?
1, 2, 3, 4.
do you mean current like old?
It says, it should say current or it should say new.
I got
So raise your hand if you got current. 1, 2, 3, 4, 5, 6, 7. Okay, we're good. All right. Sorry, I misremember things. Okay. Who was 6?
Sound like the same.
Did you get? You got the treatment.
I got the current.
The current.
Yeah. I got 20.60.
6, 7. After that was 20. New or old?
Oh, wait, old.
It says current treatment on yours.
Yes.
Okay. What did you get for your total reduction?
27.21.
27.21. All right. Subject 13.
New for
You got the new. What was your total reduction?
my total reduction. So like with it all adding up to right?
Yes.
36.06.
36.069. All right. 19.
Big ball.
Oh, I got the old one.
Okay. Total reduction
49.931.
49.931. Okay. Subject 11.
Current. And I got 45.161.
Okay. Subject 8.
Oh, I got the new treatment.
Okay. What was your total reduction?
73.3472.
73 point what?
3472.
All right.
Dang.
Next would be, so we got 14, 16, and 15. 14, what'd you get?
70.82, and I had
Got some
new.
big boys.
Okay. 16, I think.
The new treatment, and I got 98.642.
Okay. 15,
98 is
crazy.
Guys, you don't.
you got new, right?
Yes, I had and then 0.416.
For your total reduction or your random normal?
Straight off 600.
That's not right.
Yeah, total would be 80.4.
Straight off
Right?
TLC.
The
Real?
trims I got. Yeah.
Okay. Subject 10 and then 18. 10.
New, and there was 110.138.
All right. And what was the last one? 18.
New, and it was 110.041.
How did it just steadily get
Okay.
What?
Wait, what?
I'm still on top of this.
Okay. So from there, okay. What's up?
I didn't get the last few.
New treatment killing a few people. Scuffle that.
So based on what you're seeing, right? Does it seem like the treatment's making a big difference?
Yeah.
Yeah.
It does, doesn't it? Okay. So how can we check to see what an estimate for the difference is?
Confidence interval.
I could estimate what that difference is with a what?
Confidence
A confidence interval, right? So let's look at our confidence interval. We don't have time to go through the entire process, so what I'm going to ask, one thing I'm going to ask you to do is probably to actually do the state plan Duke includes so that we can talk about it tomorrow. But how would I run this confidence interval at this point?
At this point, you take averages of both treatments, and then from there, you pick one to put first, and then you take the difference, and you use that as like the center of your
Yeah.
interval. And then
How can I make my life a little bit easier though? Let's do new minus current, right? So X bar new minus X bar current. So we're trying to estimate the new minus the current. That's what we're trying to estimate. But my question is like, how can we quickly do that calculation? I don't want to go through the whole procedure. I ain't got time for that right now. What do I want to do? Calculator. Whoa. What are we going to do? And I will say this. Let's add a calculator page. Okay. So control doc, add that calculator page. What am I going to do in order to get that confidence interval?
Menu.
All right. So I go to menu. Let me do cool crap. Statistics.
Confidence interval.
Confidence interval.
2 sample t-tests. Or interval.
So we're on intervals, 2 sample
Yeah.
t interval. Right, and so Ashton's right, we could get statistics, but right now, do we have statistics or do we have data? So we're gonna leave it on data and hit OK.
What's the difference between stats?
Well, so like you have the raw data, the statistics would be you have the sample mean, you have the sample standard deviation. All right, so what's our first list? What's our first data?
The treatment,
I think it was, I named it,
it
It should be like treatment and no treatment.
yeah, no treatments here. So we're doing treatment. Bless you.
Yeah.
And then list 2 would be
not
no treatment. I should just say like control or old or whatever. Let's do a 95% confidence interval. Peyton, do I pull it or no? We never pull. Okay, so we hit OK.
Oh, we did wrong.
Oh no.
And so these are the values that we should be looking at. So looking at that interval, does there seem to be convincing evidence of a difference in the treatments? With 95% confidence, what is the difference in the treatments?
Between 30.
The way I put it in, treatment has like a
56.
Right, so with 95% confidence, the interval 30.9 to 83.1 captures the true effect of the treatment. But I gotta ask this, because one, I never would have anticipated getting that. That is very rare to get something like that. But I do want to ask this question. Did anybody get a treatment effect between 30 and 83?
Yes.
no.
Treatment effect.
No.
No, okay.
Not a single person has a treatment effect of between 30 and 83. I'm not going to tell you what the actual treatment effect is, but I want us to pause and recognize, if you look at your treatment effect, nobody has between 30 and 83. So, is this actually capturing my parameter?
No.
It is not. Let's look at something different then.
Mr.
And
King,
so, in this case, yes sir.
I keep getting errors on.
Okay, I'll come look at it in a second. Chill. Alright, so let's look at this. Is there a source, a potential source of confounding that could be affecting our understanding of the treatment?
The individual.
Okay, but what about the individual, right? Because it needs to be a variable about that individual.
The individual treatment effect?
Not the
The individual effect.
Okay, so the individual effect, but that individual effect is not, I'll say that's not a confounding variable. So age could be confounding. What else could be confounding?
Original cholesterol level.
Original cholesterol level, or the, what's the other potential confounding variable? Weight, right?
Yeah.
I got an important question for you here. Excuse me. Which of those do you think would have the highest effect on potential confounding?
Weight.
So weight. We think weight?
Yeah.
Okay. So here's what I now need you to do then. If we're going to go based off of weight, I need y'all to find out, I need us to get in order from lowest weight to highest weight. Right up here, I need lowest weight to highest weight.
I have 252.
Hey, you big boy.
252.
Hulking for real.
252.
264, we were reeling it down.
252.
Mine's lower than 130.
How are you, fatty?
Who's at the lowest?
Alright,
The effect was like
in order.
What are you?
Not the 252.
My initial 330.
Alright, so are we in order from weight?
I don't
No, we're still doing
know.
it.
138.
Okay.
And ounce.
So we already said, right, that weight is potentially a confounding variable, right? It could affect our understanding of how the treatment is affecting cholesterol. So what could I do to reduce the effect that weight is having?
Block.
What kind of block should I use?
By weight.
Matched pairs. The two people with the most similar weight should have the most similar individual effects, right? And so if I subtract their information, then that's going to reduce that variability. So I'm going to look at this block right here of Ashton and Haley. Then I'm going to look at Bryson and Logan. Then I'm going to look at Austin and Mr. Arliss. And so how am I going to make sure that I evenly distribute my current versus my old treatments?
one each pair?
So how do I decide that though? Do I just hand it to them?
Randomly assigned between the.
I have to randomly assign. And so, remember earlier, I think it was Alyssa, where you were doing the 1 and 2, right? So in this case, where I literally have two things, it would make sense to randomly assign in that way. So I could go up to Ashton and I randomly generate a number. And if he gets a 1, then he's going to get the current treatment. And if he gets a 2, he gets the new treatment. And Haley gets whichever the other one is, right? So let's keep this in mind. I'm going to tell you what you have. So menu. And I'll pass out the things in a second. Hold on, stay where you are. All right, random integer. All right, so. All right, so Ashton, you have current. Haley, you have new. Who's next? Bryson. So you can grab a seat once I tell you. Bryson, you have new. Logan, you have current. Austin, you have current. Mr. Arliss, you have new. Alyssa, you have new. Deacon, you have current. Tyler, you have new. Lexi, you have current. Aaliyah, you have current. And Peyton, you have new. And Josh, you have current. And Joseph, you have new. So I now need you to rerun that. I will pass back out the treatments in a second.
What if we already had the one that we previously had? Can we just
Then you can just use that same treatment thing. Hey, does anybody know what I did with the little... Okay, just rewrite on your old one for the same effects, and I'll need you to hand it to me in a second. All right, what did you get? You got new. Okay, you got new. You got the same. But so redo the random, and everything else can stay the same.
Don't know that.
This how you got it?
Yeah.
So confused.
Y'all have the same one? Yes. Yes. Okay. Rerun that information. You need new.
And also want to sign it, man.
No, you gotta do.
Okay, do I need to change these numbers? We got current versus new for us? You need new?
Oh, I thought it.
Oh, that's fine. But, well, you need which one? Okay, there you go.
No,
Okay,
it's the paint off. It looks like I'm repainting my nails.
Okay, do y'all have you have current now?
Literally took a whole ton of paint off.
Okay, so you still have current? Did you have the right treatment?
Same, but I'm about to do.
The random
Should
again?
we
Okay.
like actual paint or would she
Alright, sorry, we'll have to wrap this up tomorrow. Write down, oh, actually, we're staying during advisory anyway, so write down your values, hand me that little slip of paper. Write your advisory teacher's name up here so I can email them.
What do we do for the random?
Remember, random, normal, with a mean of 0, standard deviation of 2. I need this, the new one. Is the new one on here?
No, because I didn't get current.
Oh, you need a
Treatment is
current? Okay, it'll be 0. Thank you.
What about these?
So it ended up being about the same?
It was the same. I didn't do it. I did.
Okay, wait,
I had
okay.
new and then new again. Okay.
Alright, thank you. Oh wait, hey guys, hold on. You need to hold on to your subject. Which subject were you? 11. You were 11. There you go. Hold on to your subject. Who gave me their subjects already?
Me, 16.
At 18.
There you go. So remember, if you're staying to go over the free response, I need you to write your advisory teacher's name up here next to your name.
Hi, Mr. Kenny.
Okay.